And then we have the hormones of the kidney. Which are the kidney hormones? So, Arif sir has just taught you the renin angiotensin mechanism. We'll just revise that. Here we have the Bowman's cup, and then we have the PCT, and we have the loop of Henle, and then we have the DCT. And at the junction of the DCT with the afferent renal arteriole is the juxtaglomerular cells, JGA cells. Suppose the blood volume and the blood pressure becomes less. If blood pressure becomes less, then the amount of blood going in the afferent arteriole will become less, which means the amount of blood going in the efferent arteriole is relatively higher. Okay, if you remember, what goes in the afferent arteriole is more blood. What goes in the efferent arteriole is less blood. And the difference undergoes ultrafiltration. That is what Arif sir has taught you. तो afferent का diameter बड़ा है, efferent का छोटा है. Afferent से ज्यादा blood pass होता है, efferent से कम होता है, and the remaining pressure of blood in the glomerulus causes ultrafiltration. But समझो body में blood pressure ही कम हो जाता है, then what will happen? Amount of blood going in the big afferent arteriole is less. Efferent ka diameter is normal, so less blood is going in the afferent arteriole. More blood is relatively going in the efferent arteriole. So the pressure of blood in the glomerulus will become less. That's not high pressure, it's low pressure. So ultrafiltration will stop. And if ultrafiltration stops, urea cannot pass out through the urine. So this happens in case of a accident, when a person has a blood loss or severe diarrhea in which water volume becomes less and the blood pressure becomes less. तो severe diarrhea है, blood loss है, उसमें blood pressure कम हो जाएगा, means the amount of blood going in the afferent arteriole becomes less and efferent say same volume is going. Normally afferent has 625 ml and efferent has 500 ml, and 125 ml becomes glomerular filtration rate. But if blood pressure because of less blood volume due to vomiting, due to diarrhea, due to blood loss, तो afferent में 625 की जगह 500 ml जा रहा है and efferent से तो 500 ml जा ही रहा है, which means in the glomerulus the pressure becomes less, and what will happen? Ultrafiltration will stop. That means urea will accumulate in the body, and that is a condition called as uremia. तो uremia हो जाएगा, and that is dangerous for the brain. तो what to do in such condition? सर, ये है आपका बोमेंस कप और ये है आपका डीसीटी और यहाँ है juxtaglomerular apparatus. It will give out an enzyme called as renin, and renin acts on your liver, और liver में होता है angiotensinogen, and angiotensinogen gets converted into angiotensin 1 with the help of renin, and that is done by renin. So liver में angiotensinogen becomes angiotensin 1, it goes into the lungs, and in the lungs is found ACE enzyme, angiotensin converting enzyme. Angiotensin converting enzyme, and angiotensin converting enzyme or ACE will convert angiotensin 1 into angiotensin 2. ACE will convert angiotensin 1 into angiotensin 2, and angiotensin 2 will go and act on the efferent arteriole. तो once again, ये है juxtaglomerular cells, and JGSL give out renin. ये है afferent arteriole, ये है efferent arteriole, and renin will go into liver, and angiotensinogen will become angiotensin 1, will go to the lungs. Lungs में ACE angiotensin converting enzyme converts angiotensin 1 into angiotensin 2, and angiotensin 2 returns back into the kidney and causes a vasoconstriction of the efferent renal arteriole. Vasoconstriction of the efferent renal arteriole. Efferent renal arteriole. So what will happen? Efferent renal arteriole दब जाएगा. So afferent arteriole से say 500 ml of blood is going, and efferent से जाना चाहिए था 500, but now it has undergone vasoconstriction, so say now 400 ml is going. So 500 is going through afferent arteriole, 400 is going through efferent arteriole, means in the glomerulus pressure will become high, and that will lead to ultrafiltration, and glomerular filtration will take place, and glomerular filtration rate will increase, and that will help in urine formation. So beautifully, once again, if the blood volume and the blood pressure become less, then amount of blood going in the afferent renal arteriole, instead of 625 ml, will say become 500 ml. Efferent arteriole has 500 ml. Then 500 minus 500, glomerular filtration rate will become 0. Then juxtaglomerular cells found at the junction of the distal convoluted tubule and the afferent renal arteriole will give out renin, and renin will go into the liver, where renin converts angiotensinogen into angiotensin 1. Angiotensin 1 goes into the lungs. In the lungs, ACE, that is angiotensin converting enzyme, converts angiotensin 1 into angiotensin 2. And angiotensin 2 returns back into the kidney and causes vasoconstriction of the efferent renal arteriole. So how much blood is now going through efferent arteriole? Say 400 ml. Through the afferent arteriole, 500 ml. Through efferent arteriole, 400 ml. Means in the glomerulus, filtration will take place because of pressure in the glomerular apparatus, and glomerular filtration rate will increase, and that will allow urine formation to take place, will prevent a condition of uremia. Uremia will not take place, and you will have urine formation taking place, and uremia is prevented. Beautiful logic done by renin angiotensin mechanism. Along with it, the juxtaglomerular cells also give out a hormone called as erythropoietin, which stimulates your bone marrow for the production of RBC, which is called as erythropoiesis, and calcitriol, which helps in the formation of vitamin D. Erythropoietin stimulates your bone marrow, red bone marrow, for RBC production for erythropoiesis. RBCs are called as erythrocytes, and poiesis means making. So making of erythrocytes, called as erythropoiesis, is done by erythropoietin, and that will help in RBC manufacturing. And calcitriol helps in the formation of vitamin D in the skin. Skin में calcitriol की मदद से vitamin D बनता है. So three mechanisms are helping in the kidney: renin, angiotensin 1, angiotensin 2, which helps in regulating the blood pressure and allowing urine formation; erythropoietin, which helps in erythropoiesis, that is production of RBC. Yes, second logic है. Or calcitriol, which helps in the formation of vitamin D. Three associations with the kidney. No doubt, kidney is a very important endocrine gland. Anybody with a kidney failure, you do dialysis to help him remove the urea, but you also give the person injections of erythropoietin and calcitriol. इसके injections भी देने पड़ते हैं dialysis patient को, so he has RBC production and calcitriol, that is vitamin D production. ये याद रखना किडनी के बारे में. Then we have the hypothalamus. Hypothalamus has neurosecretory cells, and they give out all the releasing factors and all the inhibiting factors. All releasing factors and inhibiting factors are given by the hypothalamus, which control the pituitary gland. And pituitary is under control of releasing factors and inhibiting factors. Which are they? You have thyroid stimulating hormone releasing factor, which controls the release of thyroid stimulating hormone; FSH releasing factor, which controls FSH; LH releasing factor, which controls LH; GH releasing factor, growth hormone releasing factor, which controls growth hormone release inhibiting factor, which gives out growth hormone inhibiting factor, which reduces the amount of growth hormone, and that we remember is called as somatostatin. We've done that before. And you have prolactin releasing factor, you have prolactin inhibiting factor, you have MSH releasing factor and inhibiting factor, you have ADH and oxytocin, all hormones given by the hypothalamus. Then we have the pineal gland. The pineal gland is situated on the dorsal side of the forebrain. Ventral side, front में था pituitary gland, back side, dorsal side है pineal gland. It gives out melatonin and serotonin, of which melatonin plays a very important role in regulation of your 24-hour diurnal rhythm of the body. That it helps in maintaining the normal rhythms of sleep and wake. At around night time, 10, 11 o'clock in the afternoon, you feel sleepy and you go to sleep. And at around 6 o'clock in the morning, 7 o'clock in the morning, for your generation, it's a little delayed. You sleep at around 12 o'clock and get up around 8 o'clock in the morning. And that sleepiness in the night is because of melatonin. Melatonin levels are high, it induces sleep. And you wake up in the morning is because of decrease in the amount of melatonin. And अगर आप एक fixed pattern बना लो, which I always advise you to, sleep at around 10, 10:30 in the night and get up at 6 o'clock in the morning, that is the ideal time. 10, 10:30 ko melatonin levels are high. So you are sleepy and you follow your normal rhythm and you go to sleep and you get up at 6 in the morning, melatonin levels are low. At around 10 o'clock in the morning, melatonin is very low and you will all wake up. In the afternoon, God forbid you have a lecture to attend or I have a lecture to give around 2 o'clock, 1:30 to 2:30, again there is high melatonin and you tend to feel sleepy. इसलिए दोपहर को भी वापस से नींद आती है. So रात के 10:30, 11 के आसपास and in the afternoon 1:30 to 2:30 के आसपास you have high secretions of melatonin, which make you feel sleepy. And at 10 o'clock in the morning and at around 6 o'clock in the evening, melatonin levels are low and you don't feel sleepy. You are maximum awake at that time. So, this is your diurnal rhythm or sleep and wake cycle controlled by melatonin. Melatonin also controls your body temperature, and melatonin also influences your metabolism. So, body temperature actually controlled by thyroxine and metabolism controlled by thyroxine is influenced by melatonin, and your pigmentation actually controlled by MSH, melanocyte stimulating hormone, is also influenced by melatonin. Your menstrual cycle controlled by FSH and LH is also influenced by melatonin, and your defense capability controlled by thymus gland, thymosin, is also influenced by melatonin. So, very versatile hormone, controls your sleep and wake cycle, your body temperature, metabolism, pigmentation, menstrual cycle, and defense capability. Great hormone, melatonin. Serotonin is your mood hormone. It is the hormone which makes you feel emotions, and high amounts of serotonin make you feel happy. It is the happiness hormone, and more is the amount of serotonin, more the happier you are, and it is the happiness hormone called as serotonin. Serotonin is directly proportional to happiness, and that brings us to it. Decrease in the amount of serotonin will make you less happy and leads to depression. And so many people in the world are depressed, and that is depression due to decrease in the amount of serotonin. You go to a psychiatrist, he will give you selective serotonin reuptake inhibitors, SSRI नाम के medicines देगा. If you've heard of it, one very common medicine, Prozac. Prozac was one of the most common selective serotonin reuptake inhibitors, started in the 1980s, and it suddenly changed the logic of depression. Prozac was being given, which is a selective serotonin reuptake inhibitor. It increases the amount of serotonin and makes you feel happier. So that's a vital hormone. SSRI, serotonin, is your happiness hormone. Chali. So we have understood all the hormones. Now let's understand hormones as messengers and regulators. How do hormones act like messengers and regulators? Hormones bound on their target organs with the help of specific receptors, which are called as hormone receptors. The hormone receptors are either present on the cell membrane, that is membrane bound receptors, or maybe intracellular receptor. तो एक हार्मोन रिसेप्टर आइदर सेल मेम्ब्रेन के ऊपर हो सकता है या इंट्रासेल्युलर विद इन द सेल हो सकता है. Let's see how. You have two types of hormones: protein hormones and steroid hormones. Protein hormones will act on a specific receptor on the cell surface, and protein hormone will go and attach to the receptor surface, and receptor surface पे protein hormone act करेगा. It is called as the first messenger. एंड द प्रोटीन सरफेस के ऊपर जो रिसेप्टर सरफेस है, हॉर्मोन्स पे एक्ट करेगा, एंड द प्रोटीन रिसेप्टर gives out an enzyme called as adenyl cyclase. And adenyl cyclase given by the cell membrane acts on ATP, and adenosine triphosphate के दो phosphate adenyl cyclase निकाल देता है, and ATP gets converted into AMP, which is called as cyclic adenosine. Adenine plus ribose sugar, adenosine plus monophosphate. If you remember, it was triphosphate, two phosphates are removed, and ATP gets converted into AMP, adenosine monophosphate, which is called as cyclic adenosine monophosphate. So ATP becomes AMP. AMP acts on calcium or IP3. IP3 or calcium, IP3 inositol triphosphate. Inositol triphosphate IP3 पे ये एक्ट करता है, and calcium or IP3 now along with CAMP become the second messenger which pass into the nucleus. और न्यूक्लियस के ऊपर होता है डीएनए. द कैल्शियम IP3 or CAM, cyclic adenosine monophosphate, acts on the receptor on the gene, and that gene undergoes transcription and translation to form the desirable protein. So, how many messengers were involved? Hormone acting on the cell membrane acted as the first messenger. Adenyl cyclase enzyme converted ATP into AMP, and cyclic adenosine monophosphate acted on calcium or IP3, and AMP, calcium or IP3, acted as the second messenger. Second messenger acted on the receptor on the gene, and the gene underwent transcription and translation. This is for a protein hormone. But समझो it is a steroid hormone, estrogen, progesterone, testosterone, or adrenal cortex hormone, aldosterone, cortisol, or androgens, or as a matter of fact, thyroxine, which is a very small hormone. These are lipid soluble hormones. These are lipid soluble. What is the cell membrane made up of? Lipoproteins. So these lipid soluble hormones are able to pass through the cell membrane. They pass through the nuclear membrane, which is also made up of lipoproteins, and the hormone goes and acts directly on the gene, and hormone directly gene के ऊपर act करता है, and receptor on the gene, which is a cytoplasmic intracellular receptor, उसके ऊपर ही act करेगा. So the hormone itself is acting as the first messenger directly stimulating the gene. If it was a protein hormone, then hormone acted as the first messenger, adenyl cyclase, ATP, CAM, calcium, IP3 acted as the second messenger, because protein hormones cannot pass through cell membrane, which are lipids, but steroid hormones, which are made of cholesterol, fatty acid derivatives, and these are lipid soluble, so they will pass through cell membrane, they will pass through nuclear membrane, and they will directly act on the gene, and the gene will undergo transcription and translation to form the desired protein. So hormone itself acts like first messenger. For a protein hormone, hormone is first messenger, calcium, IP3, and CAMP act like second messengers. In case of steroid hormones, the hormone itself acts as the first messenger because it is lipid soluble in nature. So, where are the receptors found? On the cell membrane, you have receptor in case of protein hormone, or within the cytoplasm and nucleus, you have the receptor for steroid hormones. So, this is the mechanism of action of hormones, and we end the chapter types of hormones based on their chemical nature. Hormones are classified into five categories: amino acid derivatives or amines. These are amines. And you have proteins, which are called as polypeptides. And you have glycoprotein, that is glycogen plus protein. You have steroid hormones made of lipid and cholesterol, and you have catecholamines, amine with a nitrogenous substance. Which hormones were amino acid derivatives? Uh, Amino acid derivative made up of only a chain of amino acid, that is iodo thyronines or iodotyrosines. Iodotyrosines कौन था? If you remember, tyrosine plus iodide. Tyrosine plus iodide, you had thyroxine. So thyroxine is purely an amine. It is an amino acid derivative made of only tyrosine. Amino acid made of only tyrosine. And then we have catecholamines, epinephrine and norepinephrine. That is adrenaline and noradrenaline, which we remember were made up of tyrosines only. But along with tyrosines, they had an NH2 group and amino group attached to it. And because there was an amino group attached to it, amine with a nitrogenous substance, these are called as catecholamines. So epinephrine, that is adrenaline, and norepinephrine, that is noradrenaline, are classified as catecholamines. And then we have glycoproteins, that is glycogen along with protein. So it is a protein which are made up of 20 types of amino acids. 20 types of amino acids. So that is a proper protein. But along with the protein, there are glycogen molecules attached to it. Glycogen molecules attached to it. So that becomes a glycoprotein. And these are glycoprotein. You have TSH, FSH, LH, or ICSH, which are classified as glycoprotein. TSH, FSH, LH, and ICSH are classified as glycoproteins. And then you have steroids, which are lipid and cholesterol derivatives. These are hormones of the adrenal cortex and gonad hormones. Hormones of adrenal cortex and gonad hormones, in other words, estrogen, testosterone, progesterone, and adrenal cortex hormones, aldosterone, cortisol, and androgens of the adrenal gland. So you have estrogen, testosterone, progesterone, aldosterone, cortisol, and androgens of the adrenal gland, which are made up of lipids, or these are steroid derivatives. And all the other hormones are amino acids of 20 types. 20 types के amino acids है. In other words, these are amino acids which are polypeptides. तो ये है polypeptides. So these are not amines, these are proper polypeptides. All the hormones, remaining ones, insulin, glucagon, vasopressin, oxytocin, prolactin, growth hormone, ACTH, thymosin, PTH, parathyroid hormone, TCT, thyrocalcitonin, renin, angiotensin, erythropoietin, and you have gastrin, you have secretin, you have CCK, you have atrial natriuretic factor, you have erythropoietin, you have calcitriol. All these are classified as polypeptides or proteins. So once again, which are amino acid derivatives? Purely tyrosine, iodotyrosine, thyroxine, which are amino acid with nitrogenous amino group, NH2 group, epinephrine and norepinephrine, which are glycoprotein, that is protein plus glycogen, FSH, LH, TSH, ICSH, FSH, TSH, LH, ICSH are glycoprotein, which are steroid hormones or lipid cholesterol, hormones of adrenal cortex, and gonad hormones, that is aldosterone, cortisol, androgens, estrogen, progesterone, and testosterone. And what are all the remaining hormones? Polypeptides, that is 20 types of amino acid: insulin, glucagon, vasopressin, oxytocin, prolactin, growth hormone, ACTH, and we read the others, that is thyrocalcitonin, parathyroid hormone, thymosin, erythropoietin, calcitriol, atrial natriuretic factor, somatostatin. All other hormones are classified as proteins. Chali. So with that, we have understood this beautiful chapter called as hormonal coordination. And with this, we have analyzed everything about human physiology. We have understood all the crucial chapters of human physiology. Very soon, we'll be going into a new spectrum altogether, the very, very beautiful DNA and the concept of genetics, which we are starting back to back. Excellent chapters, really difficult chapters of genetics. We'll be starting very, very soon. Ciao. I hope you've understood this. Take care. God bless.